on. There it goes. All right. So we have a table on, let me repeat that. We have a table on 402A. And the first column is the prefix, the second column is the number of sides, and the third column is the name of the polygon. So the first one is tri. How many sides? 3. And it's a triangle. That's what we call it, triangle. Quadra is 4, and we call it a quadrilateral. Then after that, notice what we end up calling them. So penta is 5, and it's a pentagon. Yeah, pentagon. Hexa is 6, so it's a hexagon. So we just name them now with gons because they're so multi-sided. Gon. Octa, or hepta. Sorry, hepta is 7. Heptagon. Yep. Octa is 8. Octagon. Nona is 9. Nonagon. And deca is 10 for decagon. All right? Okay? So the number of sides. Now the number of sides also match the number of vertexes. So that's a way to count. You can count the vertexes, and you will also have the same number of sides. All right? If you have a 4-sided figure, you have 4 vertexes. If you have a 3-sided figure, you have 3 vertexes. If you have a 10-sided figure, you have 10 vertexes. All right? So they remind you that when you studied quadrilaterals in Lesson 8-1, you learned several terms that can be applied to all polygons. So the next graphic details that, right? So number 1 discusses a vertex, the point of intersection of 2 sides. Number 2 is, what do they got for number 2? Number 2 is discussing the diagonals. It's a segment whose endpoints are non-consecutive vertices. So it goes from one vertex to another vertex that's not consecutive, so it creates a diagonal. Number 3 is going to show you the consecutive vertices. Consecutive means in a row, right? Mm-hmm. And then number 4 on your diagram is going to show you the sides. All right? And those are just, they share a vertex and are called consecutive sides. So they're right after each other. And obviously non-consecutive sides wouldn't touch each other. So you've had those terms before. Now they just show you on a different side, a different polygon. This is 1, 2, 3, 4, 5, 6-sided. This is a irregular hexagon. So if you start up you find your polygon, it's got a lot of arrows and stuff pointing to it, but there's vertex P. Find vertex P in the top left. You find it? And then move to the right, immediately straight to the right, you get to vertex Q. Then at a slight angle running from like 10 o'clock to 4 o'clock, you get to vertex R. And then from a slight angle from about 1 o'clock to 7 o'clock, you get to vertex S. And then from vertex S at a slight angle from about 2 o'clock to 8 o'clock, you get to T. And then back up from T to U from about 4 o'clock to 10 o'clock, T to U. And then almost straight back up. It's kind of a little past noon. You get back to P. So there's the outline of this irregular pentagon. So notice P, Q, R, S, T, U. How many vertexes are there? 1, 2, 3, 4, 5, 6, right? Yeah. So that means there's 6 sides. All right, and if you count them, P to Q, 1. Q to R, 2, R to S, 3, S to T, 4, T to U, 5, U to P, 6. Okay, so 6-sided figure, so it's a hexagon. And then it's reminding you that you have vertexes, you have consecutive vertexes like Q and R, you have consecutive sides like R, S to S, T, and you have diagonals. This is only one of the diagonals, there's several, going from P to T. P also has a diagonal to S, if we were to draw that. It also has a diagonal to R. There's 3. Right? It just doesn't show you those three. So that's kind of the anatomy of a polygon, right? Using some familiar terms like vertexes, sides, consecutive, non-consecutive, diagonal.
So
right?
they're just basically like
They're giving you an arrow to point to the diagonal. Is that what you were asking? Yeah. And up above you have the key. Okay. All right. Turn the page. And it discusses an equilateral polygon. An equilateral is a term that should sound familiar. Equilateral means what?
All sides are the same.
Yeah, all sides of the equal are the same, are congruent, right?
Yeah.
And an equiangular polygon, what does that mean?
All angles are equal.
All angles are equal, congruent. So this is telling you, reminding you about that. An equilateral polygon has all sides congruent, and an equiangular polygon has all angles congruent. A regular polygon. So notice I said the last thing you looked at was an irregular polygon. It was an irregular hexagon. A regular polygon has both equilateral and equiangular components. So all sides are equal and all angles are congruent. So there's 3 examples of equilateral, but not equiangular. So this particular one it has the same sides, but it does not have the same angles. So therefore, this rhombus is not a regular polygon. It's a rhombus. Right? It's not a square. A square would be a regular polygon. So this it's only equilateral. So this is not a regular one. All right, turn the page.
I have a question on the drawing for 14 through 16.
All right, 14 through 16. All right, everyone. Pause. All right, number 14 through 16. Okay. You are looking at a triangle, a big, huge triangle that's outlined with a bunch of lines going through the midst of it that create another triangle inscribed inside. So let's do the outside of your triangle. So the very far left is X. And then going from west to east, go all the way over through point A and find Y, the top right vertex. That's your top side. It goes through a point A, and from X to A is 6, and from A to Y is 6. So that's interesting. You want to think about that. All right, now at Y, at the top right vertex, go immediately south all the way down through point B to point Z at the bottom right. So from Y to B is 4, and from B to Z is 4. Interesting. Okay. Now, from Z, go at an angle back up to X, about 4 o'clock to 10 o'clock. And you're going to go through point C. So Z to C and then to X. So there's the outline of your big triangle. When you go through point C, notice that from Z to C is 7, and from Z to X is 7. Interesting. Now, at all those points in the midst of your sides, A, B, and C, they have joined those together and created another triangle with inscribed inside your big triangle. Okay?
Okay.
All right. Okay, back to 10-1. We're looking at this figure, and how many vertexes do we have? 6. Good. So what? Nope. Turn the page. 6. So what kind of polygon is it? 6 sides would be what? Hex. Yeah, hex ends in an X. 6 ends in an X. Hexagon.
That's a good way to
Is that a good way to remember it? Yep. Yes. Hexagon. Sixagon. All right. Notice that all the vertexes have congruency arcs, so that's cool. We've got equal angles. But are all the sides congruent?
No.
No. So this is only equiangular. So it's not a regular polygon. It looks really cool,
Yeah, it does.
but it's not a regular polygon because it does not meet the criteria that all sides and all angles have to be congruent. All right? Turn the page. This figure should look familiar. It's a big old triangle, isn't it?
Yep.
And notice you have a congruency arc at each vertex, and you have a congruency tick mark on each side. So is this a regular polygon?
Yes.
Yes, because all sides are congruent and all angles are congruent. It's both equilateral and equiangular. So this equilateral triangle is a regular polygon. Okay? So you're going to have irregular polygons and regular polygons. The criteria for regular is all angles and all sides need to be congruent. All right?
Mm-hmm.
Okay, we are going to skip forward because this is the silliest eye candy of a tactile on the next
What
page.
the heck?
I know. I know. These people did not go to tactile graphics class.
No.
But turn one more page. We can figure the next one out. Oh, 2 pages. Sorry. Find your next
I was gonna
thermosome
say.
page on B403. Okay. So we're going to identify this polygon LMNOPQRS by its sides. All right. So here's a trick. They detailed out all the letters for you in the writing. It said little letter A down at the bottom. Identify polygon LMNOPQRS. How many letters is that? L
Oh, wait.
M N O P Q R S. 8. So how many sides do you think it's going to have?
8.
8.
Even though it doesn't look like it.
It doesn't look like it, does it? But if you start at the very top vertex L, and then you go at a slight angle down to M, we're going to go clockwise, and then we go out to N. So see how that's 1, 2, 3 vertexes? So we've got a side LM and a side MN. Then we go back in at an angle to O. That's a side. And then down to P, that's a side, OP. Then back up to Q, that's a side, PQ. And then over to the left, QR, that's a side. Then back to the right, RS, that's a side. And then back up to the top, SL. So this is a star, isn't it?
Yeah.
And it has 8 vertexes and 8 sides. So what kind of polygon is it with 8?
It's an
Octagon.
Octagon. Yeah, octagon. All right. So then is it a regular polygon or an irregular polygon?
Irregular.
Is irregular. It does not match the criteria for equilateral sides and equiangular. It looks as if it probably is equilateral, most likely. They don't have tick marks, but it looks as if most likely each side is the same because it looks like they're creating like little isosceles triangles. But the angles, we have little acute ones, and then we have these concave ones. That's what we're going to learn about next, where these angles pitch into our polygon. Those are called concave angles. So this is a concave irregular octagon. All right? There are many, many consecutive sides, and there's also many non-consecutive sides, aren't there?
Yeah.
There's lots of different choices. Name any 2 non-consecutive sides. Grab one side and then run away from it.
RS
RS, okay.
and LM.
There we go. Yep. RS and LM, not consecutive, because you've got SL in between it, right?
Mm-hmm.
Good. Excellent. All right. Now.
Okay, 17 through 19, can you describe that to me?
All right. Pause, everyone. 17 through 19. Okay. 17 through 18 is all you need. 19 is just words. So 17
Oh, okay.
18, is 3 parallel lines with 2 transversals. So the 3 parallel lines, if you find the top one, it runs from about 8 o'clock to 2 o'clock. It's in that position. And it's line X. It's labeled all the way over to the right, line X.
Okay.
Parallel to it, just below it, in the same orientation, 8 to 2 o'clock, is line Y. That's your middle parallel line. And then the very bottom parallel line is line Z. So those are your 3 parallel lines. Then there's 2 transversals, one on the left and one on the right. The left transversal is pitched at about the 1 o'clock to 7 o'clock position, and it intersects each line. They've labeled it to the left at A, B, and C. So it intersects the top line at A, the middle line Y at B, and the bottom line Z at C. They've labeled to the right the units. So from A to B, that segment is 4. From B to C, that segment is 6. Then if you move over to the right, there's another transversal that runs from about 11 o'clock to 5 o'clock. And it intersects the top line at P. They've labeled it to the left at P, the middle line at Q, and the bottom line at R. And to the right of each one of those segments, they've given the units. From P to Q is N, and from Q to R is 9.
Okay.
Got it?
Yeah.
All right. Okay, my dears, so let's go. It reminds you on the next section some information. Find the perimeter of a regular octagon whose sides are 7.6 centimeters long. If you're told it's regular, that means all the sides are the same. So to find the perimeter, this is number 3 on the next page. To find the perimeter of a regular octagon, you know how many sides does an octagon have? 8. If it's regular, they're all the same. So you're being told that it's 7.6. How would you find the perimeter?
Did you do 7.6 times
7.6 times 8, Jess. Yep.
4 times it.
Yep, just times it or add it in 8 times. That's kind of silly, but that works too, right? Okay, so if you're told it's regular, that's pretty cool. All you got to do is multiply. So on the Your Turn down at the bottom of the page, it says, find the perimeter, all the way at the bottom of the page at Your Turn, Abby. Find the perimeter of a regular decagon whose sides are 12 feet. So how many sides does a decagon have?
9?
Nope. Deca means decade.
Oh, 10.
10. Okay, so 10 sides. Each side is 12 feet long, so what's the perimeter? 10 times what, Abby? 12. What's 10 times 12?
120?
120. Excellent. Yep, 120. All right, the next couple of drawings discuss convex and concave. And the convex drawing is really, really good. The concave drawing is a mess.
Yeah.
But I will help you with other drawings to explain concave. So convex means that all the angles poke out. They point out. They're not caving in anywhere. And all the diagonals would be on the interior of our polygon. So this is an example. How many vertexes do we have? We have Q at the top, H, or excuse me, not Q, G at the top, H at the bottom right, I at the bottom left, and F over at the far left. How many vertexes do we have?
4.
So how many sides do we have?
4.
So what kind of figure is this?
A quadrilateral.
Quadrilateral. Is it regular or irregular? Irregular. Right. And then notice that it has 2 diagonals, one going from G to I and one going from F to H. Notice that the diagonals are on the interior of the polygon. So that means that all the angles are convex. They're all pointing out. Nothing's caving in. So this is a convex polygon. if we identify it by the kind of angles it has.
The other one
okay?
is a concave.
So the one we were looking at earlier, the star, it was a concave octagon because some of the angles cave in. And if any one of the angles caves in, it makes the polygon concave. So the next drawing attempts to show that, but don't even try to look at it. It's just ridiculous.
I didn't even. Wow.
What they're trying to show is that there's two sides that come in, and then there's a diagonal on the outside, but it's ridiculous. So
That doesn't even look like it.
I know, I'm sorry, but the next two drawings will help us, okay? So go to the next drawing on page B404. This one, let's count the number of vertexes. So we have T at the top, U over to the right, V at the bottom right. No, turn the page, Abby. There you go. And then R back, or excuse me, W back up to the left, and then S. So how many vertexes do we have?
5.
5. So what kind of polygon is this?
Pentagon.
Pentagon. Is it regular or irregular? Irregular. There's no congruent angles, no congruent sides. Now, notice the diagonals. They draw a diagonal through the center through the midst of the polygon. From T, there's 2 of them, right? From S, there's 2 of them. And from W, there's 2 of them. And they're all on the inside because all the angles point out. So this is a convex. Does that make sense?
Yeah.
Okay. Now the next drawing is an example of a concave. It doesn't have labels on the vertexes, so we have to just be very slow and careful, and you're going to find them. They almost feel like curves, but they're really sides. So start at the very top and go at an angle from like 10 o'clock to 4 o'clock, 11 o'clock to 5 o'clock, and you're going to come to a point just below it. And then that's going to pitch at an angle from about 10 to 4 and go out. So notice that angle on that right side, see how it comes into the polygon?
Yeah.
That's concave, and it does it all the way around it. There's a concave. But let's count the vertexes. So 1, 2, 3, 4, 5, 6, 7, 8. Did you find 8 vertexes?
Yeah.
So what kind of shape is this?
Octagon.
Octagon, and it's a concave. And is it irregular or regular?
Irregular.
Irregular. Good. So if we classified this polygon, we would say it's an irregular concave octagon. Crazy, huh?
That's a lot of work.
It is. It is. Yep, it is. All right. So that's the whole section 10-1.
Nice.
All we had to do was just learn to classify by number of sides and vertexes, classify whether it's regular or irregular, and classify whether it's concave or convex.
That's crazy.
All right.
Concave and
That is easy.
No, it's not too bad, was it?
Mm-mm.
Let's go practice. On page
Oh.
404D, we need to classify, we need to determine whether it is a polygon, yes or no, and if it's not, why not? So there's a shape down at the bottom of your page, and notice it has curves.
wow, that's weird.
Yeah.
Look.
If it has curves, a curve is not a side.
Whoa.
Side has to be a segment.
Looks like a moon.
And it does
Yeah.
kind of look like a fat
Half
moon,
a moon.
doesn't it? This is not a polygon,
Yeah.
okay?
I win.
It's just a figure. It's not a polygon. So we would say no, because it doesn't have sides for segments, does it? The sides are not segments.
Look
Okay.
like people's head. I mean,
Yeah, a little bit, yeah. All right, turn the page and look at the next figure at the top of the page and be very careful. Feel your way around this figure and notice something happening at the top. That's purposeful.
Oh.
Do you see it, Stormy?
Yeah, it broke.
It broke. So, is this a polygon?
No.
No, it's not, because a polygon has to be closed, doesn't it?
Yeah.
It can't have an opening. So this figure is
Looks
not
like
a
a-
polygon.
looks like
It
a round.
sort of kind of looks like it could be a square, but because it broke, it's open at the top. It's not a closed figure. It's not a polygon. Closed means all the sides come together, right?
Yeah.
Okay. Turn and find number 4 and 5 on the next page. All right, identify each polygon by its sides, whether it's regular or not regular, and whether it's concave or convex. So number 4, what kind of polygon is this?
Uh, quadrilateral.
Quadrilateral, good. Is it regular or irregular?
Irregular.
Good, irregular, because all the angles are the same most likely. They didn't show us, but they're probably right angles, because this looks like a rectangle, but the sides are not congruent. 2 of them look like they're the same, and 2 of them look like they're the same. They all got to be the same, don't they?
Yeah.
All right. The next one. Oh, and is this convex or concave?
They're convex.
Convex. Good. All right. Number 5 down at the bottom. This is what a stop sign looks like.
What? Really?
Yeah.
Hmm.
It's big and red and has this many sides.
4, 5, 6.
8.
Good job, Stormy.
So that's an octagon.
Octagon. Now, they didn't give us any tick marks or tick arcs. We just kind of gonna go off of feel, which I'm not pleased with how they asked this question. I would argue that, well, they didn't give us tick marks, so we don't know. But assume there's tick marks on every one of the sides, and assume there's tick arcs on every angle. Is this regular or irregular?
It is. That's regular.
It's regular. It is regular.
It kind of looks for me.
Yeah, it does. They got pretty close. And a stop sign is a regular octagon. And is this concave or convex?
Convex.
Convex again. Good. Convex. Excellent. All right. Turn the page. We got to do number 6 and 7 on the next page. It says, name each pair of pentagon, P-E-N-T-A. P is the bottom. Name each part. Excuse me. P is the bottom left, and then go clockwise. E, N is the top, T is at the right, and A is at the bottom right. So pentagon, 5 sides, right?
Mm-hmm.
Name the pairs of non-consecutive vertices. Non-consecutive vertices.
N and P.
N and P, good.
Oh yeah, I have to put down.
Okay, that's
And
1.
En.
En is consecutive.
Oh, they
Non-consecutive.
E.T.
E.T. Phone home. All right. Name another one.
They are correct.
A-N. All right, A-N. Good. Name another one. P-T. Good. Notice start at 1. Start at N at the top. And go to P. That's 1, isn't it?
Yep.
Go back to N and go to A. So there's 2, isn't there?
Yeah.
N, P, and N-A. Now go to T. Go across to E, and then go back to T, and go down to P. It has 2, doesn't it?
Yep.
Yeah.
P, E, and T, P. Go to A, and you go back up to N. We knew that one. And then we go over to E, right?
Yeah.
It has 2. Then go over to P at the bottom left. Go straight up to N, and then over to the right to T. There's 2 there, isn't there?
Yeah.
And then E goes to ET, straight across, and then EA. Okay? See how each one of them has 2.
Yep.
All right. Okay. Name any 3 consecutive sides. So each one of you, this is good, each one of you can name a pair of consecutive sides. Jess, why don't you go first?
Okay, and we're still on this one.
We're still on the pentagon.
Okay, NE, EP, and PA.
NEEP. Okay, that's just a pair, right? They just wanted a pair.
Oh, okay. I thought you said name 3.
Oh, 3. Okay. Well, I think what they were thinking of was, but you're right. Okay, so you just keep going around. NEEPPA. Okay.
Yeah.
Cool. All right. That's an interesting way to interpret it. You're right. So that's a tough one. All right. Stormy, what would you like to name?
AP.
AP.
T. T.
Yeah.
So AP or AT? AT.
Yeah.
Okay.
TN.
EN.
NE.
NE. Good. Excellent. All right, Abby.
I should
Grab one and name it. Name 3 consecutive sides. PE. EN. NT. Good. Excellent. All right. Okay, turn the page. 2 polygons on this page. You're asked to classify each polygon as convex or concave. Convex or concave. All right. So what kind of polygon do we have for number 9?
It's a
Triangle. Good. And is it regular or irregular?
Irregular.
Irregular. Good. And is it convex or concave?
Convex.
Convex. Good. All right. Take a look at the interesting figure at the bottom, number 10.
Looks like it's supposed to be a trapezoid.
It looks a little bit like it could be a trapezoid, but we've got something else going on, don't we?
Yep.
All right. Count how many vertexes you have.
1, 3, 4, 5, 6, 7, 8. What the?
So it's eight vertexes.
Wow. Yeah.
So 8 sides, right?
So
What's-
do you count this part?
Yep, you do. Everywhere where 2 segments come together is a vertex, right?
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8. I count 8.
Get it, Stormy.
You get Stormy. Find it.
7.
Counted 7. Okay.
Oh, you counted this like.
You got to count. Yeah, that dip in the middle. There's 2 there, isn't there? Everywhere there's a bend, an angle, that's a vertex, right?
7. Oh, yeah, okay.
So 8 vertexes. How many sides then does 8 vertexes have?
1, 2.
8. Good. So what kind of polygon is this?
Okay, yeah.
Yeah.
Octagon.
Octagon. Good. All right. Is it a regular octagon or an irregular octagon?
Regular.
Irregular.
And it's concave.
And it is concave. Excellent. Notice how we got a dip inside our, so if we joined the vertexes up at the top, the quote unquote diagonal would be on the outside of the polygon. All right?
Yeah.
All right. The next drawing, if you just stay on the outside of it, the eye candy on the inside is silly. But if you just stay on the outside of it, it's a shape, and they labeled the vertexes. What they're trying to, it's some sort of collar for sewing, I guess. So up at the top, there's a U, and then it dips down slightly to V, and then back up to P, and then over to the right to Q, and then down on the right to R, and then straight over to the left to S, and then slightly at an angle back up to T, and then back to U. So, and then it says, though, in little letter A, identify polygon PQRSTUV by its sides. Do you even need to look at the drawing if they tell you PQRSTUV?
No.
How many letters? PQRSTUV. 7.
7.
So 7
That's a
is a
heptagon.
heptagon. Yeah, heptagon. Hept. is 7. I don't have a trick for remembering that. I just know hex is 6 and oct is 8, so hept is in the middle at 7.
Yeah.
I mean, I guess that's a trick. All right. So this is a heptagon. Is it regular or irregular?
This one.
Irregular.
Irregular. Is it concave or convex? Concave because of that dip at the top. Yeah. Yep. Good job. All right, turn the page. Don't you wish your entire test could just be this?
Yes. Would be nice.
Would be nice, wouldn't it? All right. Identify the polygon as regular or irregular by the sides, by the concave, convex. So number 12. What kind of polygon is this? Quadrilateral. Good. Is it regular or irregular?
I would say
Irregular. Good. Is it concave or convex? Convex. Good. Okay, down at the bottom, number 13. What kind of shape is this? Quadra again. Is it regular or irregular?
Irregular.
You know, I will argue that. I'll take that argument. They're saying it's regular, but I'm really upset that they did not give you tick marks and tick arcs.
Yeah, like how are
And
you
you've
supposed
been
to tell?
taught not to assume.
Hmm.
So I would argue that if any student said it's irregular, they're right because they did not give you the information. You're not supposed to go by what it looks like,
You're
right?
supposed to go by the
Okay. All right.
Yeah, you can't not to go by what it looks like.
That's right, and you keep to that. All right. Turn the
I
page.
know it does say
Oh, was it concave or convex?
It was
convex.
Convex. Great. All right. Turn the page. What kind of shape is this polygon? Number 14.
Hexagon.
What did you say, Stormy?
Hexagon.
Hexagon.
Yes.
Hexagon. 6-sided. Is it regular or irregular? Well, according to no tick marks and no congruency arcs, it's irregular. It kind of looks regular.
Yeah.
But we're going to be good geometry students and say, you didn't tell me, so it's irregular. And is it concave or convex?
It's
Convex. Excellent. All right, turn the page. Now we got some crazy things to look at.
Oh, we have almost done with home. Oh, Jesus.
Oh, count your vertexes on this
Hey,
shape.
that looks like a letter.
It's an arrow.
Oh, yeah.
Yep.
Okay, that's what it is.
Looks like umbrella.
Looks like an umbrella. All right. How many?
5.
1, 2, 3, 4, 5,
Oh, wait,
6, 7. I get 7.
4, 5. Yeah, you're right. 7. It's a heptagon.
Did you get 7, Stormy? It's kind of crazy. Did we lose Stormy?
Yep.
Oh no,
She left.
lost Stormy.
Stormy's gone.
She got lost her connection.
She doesn't love us.
All right, well we'll just send her the tape. All right, there's 7. So a 7-sided figure is how much?
It's
Heptagon. Is this regular or irregular?
according to geometry, it's irregular.
It's irregular. It's totally irregular, isn't it?
Oh,
You can
yeah.
totally see that.
Concave.
Is it? And it is concave. Excellent, because a couple of the angles dip in. Way to go. All right, down below you got a star. How many vertexes do we have?
Holy cow, 8. I
1,
just
2,
assumed-
3,
Oh.
4, 5, 6, 7, 8, 9, 10.
Whoa,
That's
whoa,
a
whoa.
lot of.
10 vertexes. What's 10? Decagon. Yeah, decade. Decagon. Is this regular or irregular?
Gotta be irregular.
Irregular. Or is it concave or convex?
It's convex.
Concave.
That's what I meant to say.
Concave. All right, they dip in. All right, last figure. This is hilarious. It's like the biggest tactile in the whole book. I don't know why, but they went crazy. All right. All right. How many vertexes or sides?
This is human.
No,
Is the one
Joe.
actually
Well, it's
easy to-
huge. It's easy to read. They should make them all like this. shouldn't they?
Single. 5.
5. What do we call a 5-sided figure? Pentagon. We don't know if this is regular or irregular. They haven't given us tick
It's
marks.
convex.
And it's convex. Good job. All right, the bell's going to ring, so that'll be enough for today. I think you got that section, don't you? 10-1. It starts in Braille volume 37 on page 402. So I'm going to send the video to Bryant, and I'll send it to all of you just in case you want to review, okay?